This video is just a quick run through of your quiz on Introduction to Exponential Functions. It's not the same quiz you took, but it's very similar in terms of the types of problems. And if you're going to choose to retake it, the retake will be different than this as well, but similar. So I'm going to go through kind of fast like usual, but this is a video, so you're able to pause it and just let your brain absorb certain things or work things out on paper. Just some thoughts here. So like some of these questions are 2 points and some of them are 1 point. Okay? Anytime you have a 2-point question, there's probably some additional work to do. It's not just like a one and done type answer, and we'll talk about that a little more. But if it's 2 points, don't just put an answer, especially if it's wrong. You're going to lose 2 points. But if you show some work and it shows some understanding, you're going to only lose 1 of the 2 points. Because anytime you take one of these quizzes, you need to prove to me your understanding. Okay, and that's truly where your grade comes from each quarter. Okay, so this problem is you start out with 125 bacteria cells, and they double in number every hour. We've done some different ways to do this. I showed you how to make a table and things like that. But the most efficient way is to use that phrase starting amount, multiplier, number of times you're going to use the multiplier. So if we start out with 125 bacteria, there's the starting amount, and they double every hour, so our multiplier is 2. And if they double every hour for 3 hours, the number of times we're going to use that multiplier is 3. So at this point, we can either use our calculators, or if you don't have a calculator, you can write it out. But we're going to take 125 times 2 cubed, and we'll get 1,000. Moving on. Same question, but after 8 hours. Starting amount, multiplier, number of times you're going to use the multiplier, and let's see what that ends up being. 32,000. And then this last one, starting amount, multiplier, number of times we're going to use the multiplier. So about 2828. If you want to put the decimal, that's fine, but we're talking about bacteria cells. And if you show your work, show your answer, you're going to get full credit for that, no matter how you round it. Okay, these we have to identify linear, quadratic, or exponential. So with linear, we're looking for our highest exponent. We want to see x to the first power. For quadratic, we want to see our highest exponent as x squared. And for our exponential, we're looking for the variable to be in the exponent. So it's going to be some multiplier. I'll call it a, because that's the first letter in the alphabet. But then your variable is going to be up in the exponent. Okay, so pick and choose where you want to start. You can either go in order, or I think I like to say, all right, I know that exponentials, the variable is up in the exponent, so I'm just going to look for that. I see one right here, so I'm going to call that exponential. And look at that. That's 2x. X, the variable, is up in the exponent. And that's all I see for exponential. Maybe we can look for quadratic next. X squared. Look at that. It's quadratic right there. Nope, not x squared. This one, yeah, if you multiply this out, that means x plus 3 times x plus 3. You don't actually have to do this, but I'm just kind of showing you here. And if you multiply this out, and here you have that x squared. That's what causes this to be quadratic here. And on this quiz, you were allowed to use your calculator, so I know some of you were actually graphing these and looking at the shapes of the graph and being able to tell whether they were linear, quadratic, or exponential. That one's a little deceiving because you see the square there, but it has to be x that's being squared, like this one and this one. Look at that. This is x to the first power. If you don't see an exponent, it's the first power. So here and here, both of these are linear because of that. And these are like a one and done, so that's why these are just 1 point apiece. Same with these. You're just identifying growth or decay, and we're looking at the multiplier. The multiplier is the base of the exponent. So this multiplier is 3.8, this multiplier is 0.4, this is 0.99, and this looks like it's 4, but look at that negative exponent. We now know that that means reciprocal. So what's the reciprocal of 4? So 4 to the negative x power is the same thing as the reciprocal of 4 to the x power. So here's our multiplier there. If it's bigger than 1, it's growth, because if you multiply by a number bigger than 1, the number gets bigger. And if it's between 0 and 1, like a fraction between 0 and 1, or a decimal between 0 and 1, if you multiply a number by a value between 0 and 1, it's going to decrease or decay. That number is less than 1. And that number is less than 1. That's 0.25, 1/4. So those are one and done. Here, this takes a little effort. So depending on how close you are to the correct answer determines, we're approximating this using guessing and checking. So I'm not going to spend a whole lot of time. I'm going to use the shortcut, which you will eventually learn, but we're not there yet. So this answer is right around we're rounding to 2 decimal places, so about 3.80. If you want to go more than, I'm not going to mark wrong if you actually give your answer more accurate than what I'm asking for. I just don't want you to say like 4 here. You're not going to get full credit on that. And the next one, let's see. This one's about 4.14. And just so you can see that, we're looking for what value, if we take 7 and raise it to what number, would we get close to 1634. Again, the more decimals we go out, the more accurate it is. If we go out 2 decimal places, that's a little lower than 1626, or a little lower than 1634. Oops. Notice if we use more decimals, we get a little more accurate, but I would accept 3.80 on this one. Check this answer, you'll see it works also. It gets you close to 10,000. And the rest on these, all this is assessing is, can you use your calculator properly? You're basically just plugging in an x value and evaluating. Evaluate means find the value. So if we take 2 and raise it to the 1.5, we get about, it says round to the nearest hundredth again, so 2.83. Next one, 40 times 2 raised to the 2 times 2.5. Or you can do that in your head and say 2 to the 5th. It's the same thing. 1,280. Next one here, 30 times 1/2 to the 3rd power, 3.75. Last one here, 20 times 2 raised to the, I'm just going to, 0.7 plus 1 is 1.7, so I'm just going to do that. If you wrote 0.7 plus 1, you're going to get the same answer on your calculator, 64.98. That's the first page, okay? I think first time I gave you like a half an hour. If you come prepared, it probably will not take you a half an hour to do these. All right, so the setups of these, I know they're only 1 point apiece, But yes, because you could probably just do this on your calculator, but I'm going to show you the setup here. We have to take 86 and increase it by 15%. That's how we do that. I'll type that into my calculator in a minute and get that. Remember the story about percent. 15, the word percent is actually not one word, it's two words. So 15% means 15%. And if you do that on your calculator, you're going to get 0.15. So look at this one. Start with 157 and increase it by 175%. So here we go. 157 increased by 175%. That's what that looks like. Right? Just watch. 175%. 1.75. Decrease 540. 540 decreased by 32%. So I'm just going to type all these into the calculator here. 86, 1 plus 15%. 98.9. 157 times 1 plus 175%. 431.75. And then 540 decreased by 32%. 367.2. All right, next set. Different, easier way to write each expression. This is repeated addition. Multiplication comes from repeated addition. How many times are we repeatedly adding 7? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are adding 9 sevens together. Multiplication is an easier way to write that. Here's a repeated multiplication now. How many times are we multiplying by 2? 1, 2, 3, 4, 5, 6, 7, 8. So exponents allow us to write repeated multiplication more efficiently. So that's what I'm looking for there. A population of a particular city, 4,000, a real small city, 4,000, maybe we should say town, 4,560 people in the year 2000. The city has been increasing by 5%, 5%, there's 5%, per year since 1990. Okay, it's now 2021, okay, which is 21 years since 2000, and it's 31 years since 1990. Predict the population of this city in this current year, meaning today, this year. This is 2021. So the starting amount multiplier, number of times you're going to use the multiplier. Starting amount, multiplier, increasing by 5%. Number of times you're going to use the multiplier. Well, this population was in the year 2000. So we are 21 years later now. So there's the number of times we're going to use that multiplier. So let's get that answer here. Starting amount, multiplier, number of times we're going to use the multiplier. 12,704, I'm going to say, people. Right? This is 3 points. Looking for this. The setup is a little more complex than what it was on the 2-pointers. Looking for a good answer there, but partial credit is 3 points here. Partial credit is always possible when you prove that there's some understanding involved, even if you get the answer wrong. All right, similar idea here. We have an account. We're investing $3,000. It's earning 15% a year, and we want to see how much is going to be around after 13 years when we compound it for different amounts of time. So this first one is the straightforward starting amount, multiplier, number of times you use the multiplier. So let's get that answer. Okay, 18,458, we'll say. And that's money. If you wanted to go 36 cents, nothing wrong with that. I'm just looking for your understanding. Okay, same idea, starting amount, multiplier, number of times you use the multiplier, excuse me, but we're taking this 15% annual interest and now we're compounding it every month. That's 12 times a year. So now instead of once a year at 15%, we have to take this 15% and break it up into 12 tinier percentages so that by the end of the year it adds up to 15%. And we're also multiplying it 12 times a year for 13 years. So we're going to use this multiplier 12 times a year for 13 years. So let's figure out what that is. Okay, a little more money. $20,832, I'll say $33. $20,833. All right, every second, whoa, how many seconds are in a year? So starting amount, multiplier, number of times we use the multiplier, but there's 365 days in a year, 24 hours in a day. That's how many. So this is how many hours are in a year. There's 60 minutes in an hour. That's how many minutes are in a year. Youch. And that's how many seconds are in a year, because there are 60 seconds in a minute. So that's 31.5 million. I'll type it into my calculator correctly, but I'm just going to write it out as about 31.5 million. Again, I'll type this in correctly though. All right. So here we go. 3,000 times 1 plus 15% divided among, oh, I forgot that number. Just for our purposes here, I'm just going to type in 31.5 million raised to the 13 times 31.5 million. So $21,086 about. And even if you didn't use that exact number, this is a good example for that. If you said it's about 31.5 million and set that up and calculated that correctly, again, you might be off by a few cents based on what I put here. You're showing understanding. I'm going to give you full credit for that. Okay, that is the quiz. Make sure you continue to prepare if you need to retake it or make that up.